Ladies and gentlemen, boys and girls, thank you all very much for coming. It is 1600 here in the UK, it's 1900 in Moscow, and 8 a.m. on the West Coast. So good afternoon, good evening, and good morning to you all. My name is Martin, and over the next 30 minutes or so, I shall walk you through authentication and security in Diffusion. I shall introduce the concepts, I'll show them working twice, and walk you through real working code. As some of you will know by now, this webinar is part of a series, each tackling a fundamental feature that a developer will likely encounter in their development of a solution. I invite you to please put your questions to me via the Q&A feature, and we shall answer them throughout and at the end of the presentation. Simple or devilish, I'm happy to take them. Let's get this ball rolling. In this video, we're going to cover the security features inside Diffusion and Diffusion Cloud, which break down into a few categories. We will go over how the raw communication underpinnings are secured. After that, we will explore the permissioning system within and cover how it can be used to ensure data is shared only with those that it should be. And finally, we will go over authentication so you can be certain you know who is using your Diffusion solution. Most fundamentally, Diffusion supports TLS 1.3 for both WebSocket and HTTP long polling, both transports of which are used by Diffusion clients. Should it be unclear, secure communications are a wise investment when you are transporting premium, sensitive, or customer data. TLS is a secure communication protocol, so should someone intercept it, and it's wise to presume that it will be, it cannot be practically decrypted. As of February 2021, TLS 1.3, the protocol formerly known as SSL, is the latest version of TLS, and it's only 18 months old, so expect it to remain the latest for a good while. In a typical production deployment, it's common to use TLS SSL offloading in the load balancer, so the Diffusion server is relieved of the crypto overhead. This is because the load balancer is a more efficient decryptor of TLS SSL than Java's SSL library, which in turn boils down to Java lacking an unsigned integer type. That might change in the future. However, until it does, we recommend you do the same unless you have a specific need to terminate your secure comms at the Diffusion server. The Diffusion protocol itself is also non-replayable, meaning that intercepting a stream of plain text that is non-encrypted messages and replaying them will not have an effect on the Diffusion server. Going up one level to the Diffusion session, let's examine the secure aspects of that. To recap, a session is the ongoing dialogue between a client and a Diffusion server. Typically, a session represents a single client connecting to Diffusion. However, in the event of a connection failure, the session can automatically reconnect to the same Diffusion server, or even fail over to another Diffusion server and still retain its context. All sessions have a principal, where principal is a superset of username as well as other forms of identity. Sessions authenticate themselves by supplying credentials, a term which covers passwords and other proofs of authenticity, such as fingerprints, facial recognition, and JSON Web Tokens. If the session is not authenticated, it belongs to the anonymous principal, an empty string by definition. Sessions have a set of session properties which identify and describe the session. We can use these in related Diffusion functionality. The $principal session property, for example, records the authenticated principal. And combining Diffusion's messaging feature, which I shall link to here, we could, for example, send a message to each session through which a given principal is authenticated. A principal is an identity that can interact with Diffusion. A principal relates to one or more roles, and a role has a name, and most importantly, one or more permissions. This pattern is common to many enterprise applications, so if it looks familiar, don't fret, it should be. You can browse and amend the set of principals, roles, and permissions using the Diffusion console, which is good for humans, as well as in code, which will suit other scenarios, such as automated deployments. Let's explore the roles concept. Primarily, a role is a named collection of permissions. As the console does a good job of laying out, we can see both types here, global and path. Roles can include other roles, so you can inherit from and specialize them. Using either the console or code, you can create and remove roles from your Diffusion server whilst it's running. Diffusion also provides for default roles, which is the set of roles granted to each session in addition to the roles assigned by authentication handlers. We shall cover the functionality of authentication handlers shortly. As the UI makes clear, there is provision for a set of roles for anonymous sessions as well as for named sessions. This shows the out-of-the-box setting where everybody gets client, which gives you enough permission to subscribe to and send messages to message handlers and paths. Next, we'll look into Diffusion's permission system. As we covered before, the actions a client session can take in Diffusion are controlled by a set of permissions. Permissions relate to roles, which in turn are related to principals. Here we can see the console displaying a role, specifically the client role. Permissions have one of the following scopes: global and path. Starting with global permissions, which are the simpler, these govern a session's global access to Diffusion features, for example, viewing and modifying other sessions. Moving on to path permissions, this governs access to resources that have a path-based hierarchy, currently topics and request response message handlers. Let's break that down. Firstly, the topic permissions, starting with read, which grants read access to a topic. Then there's update, which grants update permission for a topic, which is discrete from modify, which grants permissions to create or remove a topic. Select lets you select or subscribe to a topic, not to be confused with read, though most often you need both. If you don't have select permission, you will need another session to select it for you. Next, with send message to, you have handler, which grants you permission to send messages to a handler bound to a matching path, and session, which gives you permission to send request response messages to another session, so long as you have their session ID. And I will link to our webinar on request response messaging here. The time series obsolete permission lets you perform unmerged range queries and return edit events for which the original event has already expired. With edit own, you can append edit events for your own original events, and edit all lets you append edit events for everyone's event. See more about this in our webinar about time series topics. And finally, all on its own is acquire session locks, with which you can acquire and release session locks, a useful feature for your own code, as well as features like update constraints. Finally, path permissions are inherited. So if you have a set of path permissions like this, where the default is pretty locked down, and FX prices is more open for consumption, then selecting topic FX prices USD GBP will work just fine. Whereas bonds FDHY matches the default rule and will be less successful. From version 6.5 onward, changes to the read topic permission are observed immediately. So if you change this permission, then all sessions using this role are affected. And we'll see a demonstration of this shortly. In this example, we're using a single path prefix matching a branch of topics. We can also use paths matching discrete topics to gain individual control over single topics. The permissioning and security API is also open and documented, so you are free to create and permission a topic simultaneously. And as you'd expect, the API functions only when you're holding the correct permission, the view and modify security permission. It's also possible to add isolated paths, a point in the tree from which the permissions are not inherited and defaults are ignored. Okay, now to the fun bit. Let's actually have a look at some real working code here in Observable HQ. This is connecting to a Diffusion Cloud instance. And after this demo, I invite you to have a look at the code, learn from it, fork it, tinker with it, and build it into your own solutions. It's there for use and reuse. What we have here are two Google Chromes, and we're using an old collection here. It's the fundamentals of Diffusion pub sub. So what we're going to do is we're going to use this demo to produce and consume some data in real time. Let's just get the producer starting up. So what this is doing, is it's established a number of JSON topics loaded with data that's real foreign exchange data, and it's replaying it at real time. So it's replaying it at the same rate that it was recorded. We can see the number of updates. We can also see the data flickering into the table there. And intuitively, it goes green and red according to whether the prices or numbers go up or down. And on the right-hand side, we're going to subscribe to them. There we go. Exactly. As you would expect, the tables are updating in synchronicity. Because the topics are being because the tables update in synchronicity with the topics that they feed from. What we're going to do is we're going to tinker with the permissions that underpin this, and then see how the user interface reacts to that. So let's get rid of the producer. Still running, and bring in the console. This is the console that's connected into the Diffusion Cloud instance. Well, first of all, let's have a look at the code, because we're not connecting with any credentials. So by default, that means we are connecting with the anonymous principal. And the anonymous principal, in this case, the default role for the anonymous principal is client. So we have a look at the client role. Here we are. Let's give us a bit more space. We can see that it hasn't got very much. It's got enough to get done what it needs to, so it can read from topics. It can select from them and can send messages to handlers. What we're going to do, let's tinker with that. And we'll take that away, but let's bring the table back so we can see the two happening at the same time. Apply, confirm that, and wallop. Table's gone great. It's stopped animating. Let's bring in the publisher. Let's see the data is, where is my publisher? There it is. The data is still being pumped in there, but the consumer does not have permission to consume, to select that. And it's been essentially unsubscribed immediately. This is how the user interface displays that. So let's quickly undo our change because it's a bit too brutal. Give back read permission. Et voila, everything comes back to life. Now, let's do something that's just a little less blunt. Let's tinker with the permissions for an individual topic. The topic is, let's imagine some GameStop scenario. We wanted to affect just an individual topic. So what this will do is eliminate read permission for just the currency pair US dollars, Canadian dollars. Save that. Apply that. Yep. And like that, it's gone. Just one row in that table has gone cold. And we'll go back to our decision. There we go. It's come back to life. So there we go. That's a real-time change in the permissions of a diffusion system in a real-life scenario. Okay, to the next major section, to authenticators. We're going to cover what an authenticator is, how they are defined and connect, how authenticators can be chained together, and then we'll study how they interact with the system properties. Finally, and for the bit I enjoy the most, we'll see an authenticator running. Let's cover what an authenticator is. As the name suggests, an authenticator is responsible for checking the authenticity of a principal, most often by checking the credentials. They are called on whenever a session connects or changes its principal. Because sessions can authenticate more than once, it's not unusual for sessions to connect anonymously, do some interaction with diffusion, consume some topics, and then subsequently authenticate themselves. Authenticators come in two types, those that run inside the server and those that run inside Diffusion clients. We've seen the system authenticator already. This runs inside the server. authenticators that run inside the server must be written in a JVM language, be on the class path, and implement the Authenticator interface, whereas authenticators running within a Diffusion client just have to use the Diffusion SDK. And we'll see one written in JavaScript later. Before they can be used, authenticators must be defined. Authenticators are defined in etc. server.xml. And here we see the out-of-the-box configuration. Notice the names of the two control authentication handlers, before system handler and after system handler, and the system authentication handler nestled between them. The order of the authenticators is significant, and we'll see how shortly. If you have awareness of production concerns, you'll be very glad to know that many authenticators can connect to a handler name, and the load is distributed evenly across them. An authenticator's interface is straightforward enough, though has some subtlety. When a session connects and authenticates, that principal and credentials pair is passed to an authenticator as part of the authentication request. When the authenticator is given an authentication request, it can asynchronously but quickly allow it, deny it, or abstain. If allowed or denied, the server behaves intuitively enough. However, if abstained, the server consults the next defined authentication handler. Thinking back to the prior slide, if the before system handler abstained, then this would be the system authentication handler. Using the configuration file, you are able to define your own authentication order. If the server has no remaining authenticators, then an abstention equates to a denial. We've seen in other webinars, which I shall link to here, how session properties can be used for messaging and for session metric collectors. Session properties come in two categories, fixed and user-defined. Let's focus on the fixed for now. These are the fixed properties, which are defined by the server. That's what they mean. They're defined by the server, and for the most part, they are immutable. When you need to message user Bob everywhere that he's logged in, then $principal is what you need. If you want to measure data spent on users in, say, Italy, then a metric collector using $country is what you need. While authenticating a session, an authenticator can add user-defined properties with names that fit your use case. Let's say left-right-handedness for smartphone users, service tier for financial solutions, favorite teams for sport betting solutions. Clients can also propose session properties at authentication time, and the authenticator must choose what to do with them. You might choose to record all of the user browsers as a session property, which would make for some genuinely useful session metrics. How many of my audience are still using IE11, for example? Or more reasonably, how many of my German customers are using Android or iOS? So enough of the slides. Let's move on to the code. Okay, let's have a look at the Authenticator, and we'll have a look at a real-life Authenticator. This Authenticator, the Authenticators are more typically implemented in systems programming languages like Java and C and C#. This one's implemented in JavaScript, so I can run it inside my browser here. But I'm using JavaScript here for two reasons. Firstly, because every solution uses it, because every solution will be using the JavaScript client, more usually as a consumer of data rather than a backend component, backend function like authenticating. And secondly, because it's not as dreadful as the JavaScript that we remember from the 90s. These days, it's more functional, it's more declarative. And in environments like Observable HQ, it's almost quite pleasant to work in. But it also means that we can just talk in terms of one language. We don't have to take our head out of one programming language to put it into another. Anyway, I'll stop talking and actually show you the good stuff. Here we are in the collection here for authentication and security. Let's have a look at a real-life authenticator. There we go. So there's two parts to this. What we're looking at here is the user interface. We have the table of acceptable principals, we have a log of authentication attempts. Underneath that is the implementation. And there's not really very much to it, so let's go through it right now. The first thing we have to do is we have to establish a session. And interestingly and importantly, here we are connecting with principal and credentials, which grant us permission to be an authenticator. Not everybody can be an authenticator, obviously. And we just log the session ID so that we know that we are connected. And then we plug in the authenticator object. There's a few pieces to that. First of all, there's the name, and this has to tally with the set of names in etc server XML on the server side. So in this, we're just using the built-in after system handler, built-in out of the box system handler. And the second thing is an object with 3 properties: authenticate, on close, and on error. Now, on close and on error are trivial enough that they're implemented in place here. Just log the details. Authenticate, there's a little bit more to it, so I've broken that out into its own function. And we can see the arguments it's given is the principal and the credentials, the existing session properties, the proposed session properties. And those two are different because we may be dealing with a session which is already connected, has been connected for some time, may already have authenticated and been granted session properties. And it is now authenticating a second time with additional proposed properties. And it's up to the authenticator to choose what to do with those. It may ignore them. It may selectively merge them, may veto them. And then we get the auth callback object, which we use to call back to the server to say, this is good, this is bad, I don't know. Log some details. And if the principal is in the principals table, then we'll check the username. If they're not, then we will abstain. So if we don't know about the users in the table, we'll simply shrug and tell the server, oh, well, I don't know who this guy is. So if you can find somebody, that would be great. But if we do know the principal, we're looking, then we'll check the credentials. If the credentials match, then we will, importantly, call auth callback allow, either with or without properties. Now, the properties in this implementation is a merge of the proposed properties as well as the user properties that we've defined in the table. There is a big note here saying don't do this in production because you don't want to blindly trust the proposed properties. Reason being is that some of the static properties that you can set here are extremely potent. The most potent of which is this one, $roles. Because you can set the role that a principal has or a session has at authentication at this point. So if somebody authenticates as user A, they're going to be given the trader role, which will affect the set of properties, the set of permissions that session has, which is of great importance. So this thing I'm doing here, don't do this thing. There we go. So if the user is known, we will allow them. There we go there. If the user is not known, we will deny it. We will give it an explicit no. Whereas an abstention is a shrug back to the server saying, I don't know who this guy is, but maybe somebody else does. And that's it. Let's see it in function. Let's try it out. Now, this is the other notebook in this collection. Its responsibility is to place sessions, to connect sessions. So let's do that. I'm going to connect to our Herb server. And in order for the authenticator to get involved, it has to be, because of our implementation, either user A or user B. So let's connect as user A. And I'm going to give it a bad password. There we go. The connection attempt was rejected. And indeed, the authenticator has logged that. Let's type in the right password this time. There we go. So 2 things happened. First of all, the result was successful. But also what's interesting here is that we get to see the session properties associated with this session. So this client has explicitly proposed a set of properties when it's connected. Here we are, it's this line here. The server details has this additional property called properties. And we're just harvesting a bunch of details from the browser itself. Let's jump to the implementation. There we go. Just a bunch of things from the environment that it's running in. So we can see the sort of browser that it's running upon. Let's then connect as somebody which the authenticator does not know about, say mysterious user X, and it doesn't matter what password it is here. Return. Now the client is trying to establish the session, got the same outcome. It basically was denied connection. But the authenticator, on the other hand, the result was an abstention because it did not know what user X was. If a subsequent authenticator in the chain of authenticators gave a thumbs up, gave an allowal, then at that point, then they would still get a session. Okay, so that's a real example of an authenticator and a client interacting with Diffusion and authenticating its session. Let's get back to the slides. Okay, now let's we'll just quickly take for questions before we wrap for the day. Looking here, we get a good question here from Joe. Joe asks, when I connect to an authentication handler, it fails and it logs no server scope control point for my system handler. Okay, that's a good question. I made the same mistake myself. The authentication handlers are bound to names, and those names must be present inside the configuration file. And my system handler, I'm guessing, is not one that exists inside the etc. server XML file. Instead, there are some presets you can use in there, or you can add your own and then it will be consulted in the order that it's listed in there. So that's just something to bear in mind, and also takes an amount of coordination with your server team, or to make sure that everything is where you expect it to be inside the configuration. Checking the next question. Alan asks, why does Diffusion use HTTP for its transports? Well, ideally, it wouldn't have to. WebSockets is what it uses in almost all circumstances. However, when a WebSocket fails, it will fall back to using HTTP long pole. It'll actually use two simultaneous HTTP sessions. That's not the right term. It'll actually use it will use two simultaneous HTTP transactions, one to deliver messages and one to consume messages from the Diffusion server. The reason that it exists, the reason that WebSockets might fail is usually down to two things. Either local middle boxes disallowing them. So we're talking here about proxies or routers or firewalls disallowing or not understanding what a WebSocket is. And in that circumstance, then it's good that your end consumers can cascade downward, can fail down to using HTTP long pole. It's not as efficient, but by hook or by crook, you'll get a session into your Diffusion server. And there've been real circumstances out in the field where that has paid dividends, and the HTTP transports available, off the top of my head, available inside the Android client, the Java client, and the JavaScript client. Okay, another question from Alan. In the example you set user A's $role system property during authentication, I thought session properties starting with $ were immutable. Well, they are certainly immutable once set. And there are a few of them which can be set during authentication, and $role is one of them. And this is an opportunity for your authenticator to say, well, I recognize user A, and he or she belongs to this role. I recognize user B, and he or she belongs to these roles. So it's your opportunity to both authorize them and also nominate them into a role. Obviously, it's important that you don't take $role from the proposed system properties. Otherwise, you could leave yourself open to a great big gaping security hole. All right, and our final question is from Navina. Aren't path permissions really topic permissions? Why the different name? Path permissions do relate to topics, but they relate also to other things that use paths. And the other thing that uses paths is request response messaging, because that is done to a path. It's a different path, rather, it's a path namespace, not to a topic. And this is a good way of constraining which of your audience of sessions, which of your audience of end consumers is allowed to send messages to handlers to do things like buy or sell financial instruments, or place or lay bets, that sort of stuff. You'll only want to let authenticated users usually do something as sensitive as that. So it relates to everything that has a path, and right now they are topics and they are message handlers. Okay, no more questions? Good. Okay, so that's a wrap for today. Thank you all very much for coming. We've covered Diffusion's authentication and security features, how it's layered throughout the product, and how you can weave it into your own solution. You can try it all out at this address. And to save your eyeballs, I will put that link into the webinar chat. I'll also put it into the video description on YouTube. Be sure to subscribe to our YouTube channel and click the bell to get notification of when the next video is published. For now, however, thank you all very much for coming, and be sure to come back next month.